Number 1.
Well, I want to say the answer is 60, but that's just because it looks like a 30, 60, 90.
It does,
But
doesn't it? But
it does
let's,
look like that. But then it wouldn't make sense because if 60 is x, then 2x is 120 and not 90.
okay. So what's the algebraic formula we can use to solve for x?
It's a squared plus b. Well,
That's if
that's
it's a
pi.
right. That's if it's a right triangle. This is not
Triangle.
necessarily a right triangle.
Triangle. It's because it's not always what it looks.
Well, what's the most important thing you can know about triangles is that the sum of their angles equals
It's
180.
180.
So what can I write?
So 180. Yeah, plus 2x plus x is equal to 180.
Now let's solve that equation.
So that is 3x is equal to 3x is equal to 180 minus 30, which is 150. And then x divided by, and that would be 50, right?
Right. So actually x is 50 and 2x is 100. So that's
Yeah.
not a right angle there.
But it's just when you see it, but then it makes sense because you said, oh, it could be a 30, 90, 60, but that wouldn't make sense because it would be too much when you calculate the others.
Right. Right. And that fact about triangles is probably the most important fact you can remember, is that the sum of the angles equals 180.
Yep.
Okay, so let's look at 2.
If the difference between the measures of the two smaller angles of a right triangle, when it says right triangle, it means that one of them is 90 degrees, right?
Yes, that one right there. So we'll
Is
call this
80
one
degrees.
A, we'll call this one B.
What is the measure in degrees of the smallest angles? So what it's saying is A minus B equals 8.
Okay. What else do we know about A and B?
They're less than 90.
They actually equal 90.
Oh,
In other words, the two
yeah.
small angles of a right triangle always equal 90. So A plus B
B
equals
equals
90.
90.
And they want the smallest angle. So we're actually solving for B, right?
Mm-hmm.
Okay. How do we solve these two equations and two unknowns?
You say A minus B plus 8 minus 8 is equal to A plus B minus 90?
Well, no, we can't state that this is equal to that, but you can always add equations or subtract equations.
Oh, yeah, okay.
So if we add these two equations together, what do we get?
Oh, you plus them together?
Uh-huh.
Well, you get 98 on what? 2A equals to 90.
Notice
98.
that the b's cancel. In other words, this is solving by elimination.
Mm-hmm.
So A is equal to, and
49.
what is B equal to?
41.
Okay, and that's our answer. Now, the trap here was that when we solve these two equations, we're solving for A because it's really the easiest thing to solve for.
Mm-hmm.
And then you have to make sure that you answer the question, which is what's the smaller angle? And
Mm-hmm.
A is actually the bigger angle. The moment you say A minus B equals 8, you're saying A is the bigger angle.
Mm-hmm.
Now, let's just go over the math here. you can add or subtract any two equations. So even though the easiest way to solve these two equations was to add them, we actually could have subtracted them and immediately solved for b. Notice what we get if we subtract the second equation from the first equation. The a's disappear. We have minus b, well, that's minus 2b. We have 8 minus...
plus b.
Well,
minus b
minus
b.
b minus plus b. Okay, and now
Okay.
8 minus 90 is minus 82. So now when we solve for b directly, we get 41 directly. So it's actually a little bit quicker to subtract the two equations rather than to add them. But that's just a subtle point. You want to make sure you know that you can add or subtract equations. And that's about it. Notice that if I have a plus b equals c, and I have d plus e equals f, I can subtract this equation from that, or I can add this equation to that. So that, you know, a plus b plus d plus e equals c plus f. Or I can subtract them. But I can't square them both or anything like that. So, okay, number 3. We have an equilateral triangle.
Does that mean that the two sides, I'm just trying to learn my English words, does that mean that two sides of the triangle are the same?
Means all three are the same.
Okay, because the other one is called ISO or something, right?
Isosceles.
Nice. Okay.
This is isosceles. This is equilateral.
Okay. I get them confused because we don't have those words.
Equilateral is 3 equal sides and 3 equal angles, whereas isosceles is just 2 equal sides.
Okay.
Okay, so if we have an equilateral triangle whose altitude is 6, that's the altitude.
Yeah, in Denmark we call it the height.
Right. So, first of all, let me tell you that there is a formula for the area of an equilateral triangle. That's what it is.
I've never seen that one before.
Well, it's not that common because we can always figure it out. Let's go through the process to figure it out. Let's look at this triangle on the left. Give me the angles of this triangle. I know that's 60, and I know that's 6. We need to figure out the measurements of the rest of it in order to be able to use the area of a triangle formula, which is 1/2 base times height. Well, we know the height. Go ahead.
We know the top one, I mean, I would say that this would be a 60, 30, 90 because you know the top is 60 and therefore it's got to be, it's got to be a 90, so and then that would make it, that is 6, and then so then the one opposite, it would be 2x, and the one would be x, what do you call it, the thing that's on the answer and then has a 3 under it. I can't remember what the English word is for it.
There's the dimensions of that triangle. In other words, if I look at, and this is pretty key also, if you can, you're going to get lots of questions about similar triangles. You know what similar means? They have the same 3 angles.
Yeah.
Okay, so here's one of our special similar triangles.
Mm-hmm.
And I like to call this my unit special triangle because opposite the 30 is 1, opposite the 60 is square root of 3, opposite the right angle is 2. So any triangle that is a 30, 60, 90 is going to have these measurements as their proportion, or 1x, root 3x, and 2x. In other words, any multiple of these. These could obviously be 10, 20, and square root of 3 times 10. Okay? So these don't have to be 1, square root of 3, and 2, but that's their proportion.
Mm-hmm.
So,
well, those were the ones I thought, so.
Yeah, so we're trying to figure out what x is. The only information we have is that opposite the 60-degree angle, it's 6.
Mm-hmm.
So how do we figure out what the measurement opposite the 30-degree angle is?
You take the thirds, no.
They're proportional. Let's erase that and that and that. And this is all the information I'm giving you.
Uh-huh.
And because these two triangles are similar, we know that the ratios of the sides are proportional, right?
Mm-hmm. Yep.
So what is opposite the 60-degree angle? 6.
6.
What's opposite this 60-degree angle? Root 3. So that has to be equal
To x.
Well, to the side that's opposite the 30, which is x, divided by 1.
Mm-hmm.
So x is actually equal to that, 6 root 3. 6 divided by root 3.
Yeah, I mean, I can see it when you do it, but I would never have gotten there.
Well, I tell you what, let's back up here. Let's make a simple one first. What made that problem hard is the fact that one was an integer and one was not.
Mm-hmm.
If I told you that I have a triangle that's a 30, 60, 90, and the side opposite the 30 is 3, what's the hypotenuse of this triangle?
6.
Good. And what did you do? You found out the ratio of the two triangles was a 3-to-1 ratio.
Mm-hmm.
And then we multiplied that 3-to-1 ratio by 2 to come up with 6. Well, what's this side here opposite the 60?
3 square root 3.
Right. So that's the way we solve similar triangles.
Mm-hmm.
However, in our particular problem, they gave us 6 was this side here.
Mm-hmm.
So what we really want to do is to figure out what's the ratio between this triangle and this triangle. Well, it's 6 divided by root 3. In the other one, we did 3 divided by 1. So we're going to take the bigger triangle, divide it by the same side of the smaller triangle, and that's going to be what's called our similarity ratio. That is the ratio that every side has to have to every other side. So what would this hypotenuse be right here?
It would be like 2 times that.
Yes, you got it. That's exactly what you want to do. You just want to take that similarity ratio and multiply it by this 2. So that hypotenuse would be 12 over root 3.
Oh, yeah.
And I understand that you shouldn't have rational numbers in the denominator, and we would rationalize that by multiplying it by root 3 over root 3, which would give us 12 root 3 over 3, which would give us 4 root 3. So this would actually be the answer we would want to give for the hypotenuse. But as far as...
when you do that, you just say 3 goes up and 3 is equal to 3. You have to multiply 3 with 4 to get 12. And then you just keep the square with 3.
Are you talking about when I rationalized it?
Yeah, because
Okay.
I totally understand that you said, when you rationalized it, you said, well, you have to...
So we're doing this problem right here. The way I rationalize this is to get rid of the radical sign in the denominator, and I do that by multiplying it by 1.
1, yeah.
Only the 1 is root 3 over root 3. Now I multiply numerators, multiply denominators.
So,
Simple.
oh yeah, because that goes out. So it's just the square root that disappears, and then you have 3, and then you say that 3 is equal, like 3 times 4 is 12, and then you can't...
Well, I get the 4 by dividing that 12 by that 3 right there.
Yeah, that's what I just said. I'm sorry. Sometimes I have to explain it. Yeah.
That's okay.
Yep.
So back to this problem. Back to this problem, we're going to take the similarity ratio, which is 6 divided by root 3, and we're going to multiply it by this side, 1. So that's our answer, except, well, let's rationalize it. So how do we rationalize 6 divided by root 3?
So you say times root 3 over square root 3 over square root 3 divided by square root 3.
So that gives me that. What does that simplify to?
2 square root 3.
And so that is 2 square root of 3 is this measurement here. Right? So what's the area of this triangle? And just as standard practice, I would always begin these. Now with triangles, you maybe don't have to do it, but always start with your general formula.
That's what I was just writing down on my paper. Obviously, you can't see that.
I think it's an excellent idea to do. Always. If you're talking circles and circumferences or circles and areas, start out by writing this formula. Okay, well, we know quite a bit. We know the height.
Which is 6.
What's the base?
Well, the base is 2 times 2 square root 3.
Which is?
4 square root 3.
And what is that answer? What does that simplify to?
Well, if you take half of 4 square root 3, wouldn't that be 2 square root 3?
Okay.
And then you have 2 square root 3 times 6. That would be 12.
Answer number B.
Yep.
Now, if I happen to know the formula for an equilateral triangle, which is probably worth memorizing,
Okay.
because you're liable to get a question like this. And notice how much simpler, well, this wouldn't be that much simpler to solve based on this formula because we don't know S. We have to figure out S. So regardless...
Where is S in the triangle? I've never seen the...
S is the side. In other words, since it's equilateral, S is the measurement of the side.
Okay.
Well, they didn't give us that. They gave us the altitude. So since they gave us the altitude, we kind of have to go through the process of figuring out this 30, 60, 90 triangle. There's no other way to do it. Since we don't have an area based on the altitude, we have an area based on the side length. But if they were to give you the side length, notice that the side length here is 4 root 3. right?
Mm-hmm.
That has to be squared. So this should give us the same answer. We came up with 12 root 3. Well, if this is equal to root 3 over 4, what is this squared?
Squared?
Uh-huh.
It would be 3 over 16.
Well, it'll be 16 times 3. In other words, you have to square both of these. You square the 4, which is 16, and you square the root 3, which is 3.
Oh, I thought you just said the square root 3 divided by 4 in squared. That's what I thought. Sorry.
You can't cancel this 4 with this 4 because this 4 is being squared, but this 4 here is not.
I know. I jumped, so I was like, oh.
Okay.
So yep, I got it.
Now we can do that, multiply this by 4, and we end up with 12 root 3, which is the same answer we got before. So
why are you multiplying? Oh, because you take it out and it gives 4. Okay. Yep.
Okay. Good. Whether it's worth memorizing that for an equilateral triangle, I'm not sure, but it does speed that up. If you happen to get a different kind of question that gave you the base instead of the altitude, then you could answer it instantly with that formula, and you wouldn't have to go through comparing similar triangles.
Mm-hmm.
Okay, how about number 4?
Two sides of a right triangle are 12 and 13. Which of the following could be the length of the third side? Well, it says it's a right triangle, so you must be able to do a squared plus b squared is equal to c squared.
Okay.
So 12 squared is 144.
Mm-hmm.
13 squared is not one I know by heart.
169.
169. It's 313.
Okay.
So that would be equal to c squared, would be 313.
Okay.
So
what you've just said is that if we had 12 there and 13 here, this one would be the square root of 313.
yep, so the answer is E. I was just going to be like, that's the only one that works of those numbers.
Actually not. In other words, this is a bit tricky. And they may not have these kind of questions on the GMAT, but notice this says indicate all possible lengths.
Okay.
There is another combination that works.
It's 5, 12, and 13.
Good. I was just going to say, if you don't know this triangle, you should know it. We have a 5, 12, 13. Another perfect Pythagorean triangle is 3, 4, 5. You want to know those two.
And there's one more, it's 9, 40, and 41.
Well, there's actually another one before that, 8, 15, and 17.
17.
So those are your 3 first. This is the lowest one, this is the next lowest one, and this is the third lowest one. I doubt that you'll have to know any more above that one. In fact, I wouldn't worry about that one. The only 2 they're going to ask you about are going to be these 2, where it's helpful if you memorize that. So what's another possible length then?
5.
Right.
Well, great. I did remember something.
Yeah. Well, the Pythagorean triangle, here, let's just go through this because there's few things more important than this. What is x?
Well, you just have to do reversed.
Yeah, but I want you to get to a point where you don't have to go through the whole formula every time to figure it out.
Well, that would be 5.
No, actually not, because just because a triangle is a 3, 4, 5 triangle doesn't make it a right triangle. It's only a right triangle if 3 and 4 are the two smaller sides. It's
Oh, so
not
yeah, the
5.
number has to be smaller.
Right. The hypotenuse is always the largest
The
side.
longest,
So
yeah.
how do you solve for C? Let's go down here and solve for C. What is C equal to?
The square root of A plus B.
If I take the square root of both sides, I get C is equal to the square root of A squared plus B squared.
Oh, now
So,
I know what you mean.
okay.
So,
So if you're solving for the hypotenuse, you want to go directly to that. If
you're
you're solving
saying that
for
C
A,
is
what is A equal to?
the square root of B. Oh, C squared minus B.
These are the two you want to memorize, because you're
Yeah, so it's
constantly going to have to solve for either a hypotenuse or one side. So rather than memorizing just the Pythagorean theorem and going through the algebra each time, it's really helpful if you can jump directly to it. So
that's the same thing where you say that the third side has to be smaller than A plus B, and the third side has to be bigger than A minus B.
okay.
It's
So
in the
in
same
our case here where I said give me x, what is x going to be?
It's 1. 1.
Well, x is A, so it's the square root of the hypotenuse squared minus the other side squared. So x is actually square root of 7.
But why?
In other words, you want to always start with one of these two formulas. I mean, this is the Pythagorean theorem here. Okay? This is the
I
way
think
you
it's just
solve.
because I thought that the square, if you square root something that is squared, it takes them away and it would leave A plus B. I think that's what I was thinking. But
No, the only thing you really need to memorize is A squared plus B squared equals C squared. This allows you to solve this and this. It is going to be faster for you if you memorize those two right there on the bottom. And this is the hypotenuse, and this is the either short side. In other words, A is the square root of C squared minus B squared. B is the square root of C squared minus A squared. So if you're solving for one short side of a right triangle, it's better to go immediately to that. It'll just be a lot quicker. Okay.
Yep. Note taken.
Number 5. They want the measurement of P to S. This is a two-step problem. In other words, we need to solve that right there before we can solve PS. What's S equal? What's X equal to?
Well, you don't know that.
We know 20 and we know 16. What's this side right there?
Oh, well, that's the whole formula you just told me.
Okay, let's do it.
So A would be equal to the square root of, so 20 squared is 400, and 16 squared is 6, no.
Okay, that's one way to do it, the way I just explained. But the better way to do it is to search for 3, 4, 5 triangles or 5, 12, 13 triangles. Is this one of...
So it's 12.
Exactly. That's the quicker way to do it.
Okay.
Okay?
So you search for those first, and if those don't exist,
Always. Then rely on the Pythagorean formula. But they put so many 3, 4, 5 triangles and 5, 12, 13 triangles in these problems that if you know those triangles, it makes these so much quicker.
Yeah.
So x is 12, and now what's PS?
13.
Saved 30 seconds over doing it using the Pythagorean formula.
Yep.
Okay.
If the measures of the angles in a triangle are the ratio of 1, 2, from 1 to 2 to 3, and if the length of the smallest side of the triangle is 10, what is the length of the longest side? That is interesting. I'm not really sure how that will work.
Okay. Let's call those angles x, 2x, and 3x.
3x, yeah, because that's the ratio.
Okay. So what is x going to be?
1.
What's the single most important thing to remember about triangles?
That they all give 180.
Okay. So we got x plus 2x plus 3x equals 180. What is x equal to?
Sorry, I'm writing.
It's okay.
Well, that would be 3. 30?
Uh-huh. Okay. So the triangle then is what kind of triangle?
It's a 30, 60, 90.
Right. And we know what the basic dimensions of a 30, 60, 90 is. What are they? What's opposite the 30?
X.
What's opposite the 60?
X square root 3.
Yeah, we generally put the number in front of the x, not afterwards.
Okay. In the GMAT book, they do it the other way.
Okay.
And then 2x.
Okay. So they're telling us that if the length of the smallest side is 10, well, this is the smallest side. What's the length of the longest side?
20.
Exactly. Since the hypotenuse is the longest side. Okay, good. About number 7.
What is the value of x in the figure above? Well,
what do we know about this triangle? What kind of triangle is it?
isosceles.
Okay. What do isosceles triangles have besides having 2 equal sides? What else do they have?
They're two equal angles.
Right. So this angle opposite that 50 has to be equal to the angle opposite that 50.
Mm-hmm.
Since this one is 50, what are these two angles? If they're equal.
70?
That would be 70, 70, and 50 would be 190.
So 60?
65.
5.
In
Yeah,
other words,
65, because 60 is
take
120.
180 minus 50 and divide it by 2.
Yeah.
So that's
That is
130 over 2.
130, so that's
65.
65.
So this one's 65, this one's 65. And if this is 65, what's x?
Mm. 115?
Correct. Okay. Almost every one of these problems is a two-step problem. In other words, you have to figure out the first thing, which allows you to figure out the second thing.
Mm-hmm. In the figure above, what is the value of x? Is it possible to draw? Because
I know it's a little hard. It's a little hard to see this. That's 30.
Yeah.
That's W, which is what they're asking about.
They're asking about double. It looks like an X.
I know. Well, that's just because I took these pictures with my camera, and boy, if you don't hold really steady, they come out blurry. So unfortunately, I didn't have a steady hand on the day that I took these. But it's okay as long as you know that's 30, that's W, that's 50, and that's a right angle right there.
Okay, so I would say that 0, 9, 14. Okay, so so where it says 50, 90, that little thing is 40, which would be equal to the one on the other side.
Okay, those vertical angles. So this is 40. That makes this
and then
40. And if this
40,
is 30,
and then you have 30.
so what's W?
That's 70. So then you just need to say 180 to minus 70, which is 110.
Right. If you want to do good at geometry, be able to subtract from 180. Because so many geometry problems are 180 minus something.
Mm-hmm.
Okay, how about this one here? Let's see. What's the area of BED, which is this shaded region here?
Mm-hmm.
This measurement is 4, this measurement is 5, this measurement is 12.
Well,
shaded region problems are what kind of problems?
I don't know a word for it,
I take that back. I take that back. In this particular case, they're not. Usually, if you have a shaded area problem, what I'm talking about like that is if I said, what's the area of this shaded region in this circle? Well, probably you need to take the area of the whole circle and subtract out the area of the white. In other words, typically,
that's what I was going to do.
Typically shaded region problems are subtraction problems. That's what I was looking for, is they're subtraction problems. But then I looked at
that's exactly what I was about to do.
Well, I was going to do it too, and then I realized you don't have to do that here. You can do this one very straightforward. Area equals 1/2 base times height. You don't need to do this the roundabout way of subtraction. You can do it directly. What's the base?
12.
Actually, the base is 4.
Oh, you have to turn it around the paper.
Exactly, because we don't know this measurement.
Yeah.
And
So
even if
4.
we did, the height would be some odd thing there. So you have to take the vertical height. So in order to look at this as a base times height problem, it's just 4 is the base. What's the height? The height is
12.
vertical height. In other
It's
words,
12.
yes, if I turn this triangle, rotate it at 90 degrees to the right, then you'd be looking at it like this. And this is 4. And the vertical height is from here to here, which is 12. So the area is a very simple 24.
Yeah.
And we don't have to find the area of this big triangle and subtract out the area of this white triangle, which would be another way to do it, but unnecessarily complicated in this particular problem.
Yeah, that was exactly what I was about to do.
Well, it would have worked. You'd have gotten 24 still.
Okay, what is the perimeter of angle BE and D?
Well, of triangle BED. BED is the shaded. So now we do have to put some numbers on these sides. Perimeter is the surrounding.
It's A plus B plus C.
Right. Okay.
You have 1, that's 4.
That's 4, exactly. What's BD equal to?
The diagonal.
Well, what number is it? In other words, if this is 4, this is 5, and this is 12, what's BD? What's the hypotenuse of the big triangle?
Well, it's 9 and 12.
Always look for your 3, 4, 5 triangle.
Yeah, so 9, that is 3, that's times 3, so it would be 15.
Okay. So this is 15. And what is this measurement right here? Right, because that's a 5, 12, 13 triangle. So what's the perimeter?
32? 36?
No, 32 is right. 28 and 4. 32.
Yeah, 32.
We were looking at the answers from the previous problem. That's why 32 wasn't on there.
I was like, did I calculate wrong?
I know, I did the same exact thing. I looked and I says, well, 32's got to be right. How come it's not on there?
I mean, if that had happened to me, I would probably have chosen 30. You know, if that would happen, you just choose the one that's the closest to you because...
Yeah, right. You assume you made a mistake and whatever's closest, right?
Yeah.
But usually, if you come up with an answer and you don't see it on there, you've done something major league wrong. And if I'm taking the test and I come up with an answer that's not amongst the 5 answers, I'm going to go back to scratch and redo the whole problem. Because it indicates that I'm pretty good at arithmetic, so I don't think I made an arithmetic error, but I might have made an error in analysis. I might not have done the problem correctly. So, okay, let's see this one here. Gosh, I can hardly read this. They want the area of this shaded region, DHF. Oh, man. I'm trying to read this. Let's see, that's 3, that's 5, that makes this 4.
4.
So the only thing we need is HF. This is 7. So HF must be 3.
Yeah.
So what's the area of the triangle? If HF is 3,
And then it's half Oh, sorry, 1 second. It's half 3
times.
and then it would be the height of there, which would be 3.
Okay. In other words, that's the vertical height right there of that triangle.
Uh-huh.
So this is kind of like the other problem, only they put this on its base.
Yeah.
Okay.
So it would be half,
Half
it's
of
3
9.
times 3.
Right. So 1/2 of 9 is 4.
9 is 5, 4.5.
Right. Okay. And what's the perimeter of that? Again, we have to just finish putting some oops, wrong one. This one here. So let's see. I can redraw.
You have 5 and you have 3. But it cannot be...
So we figured out this side here was 3.
3.
This side is 5. So we need that side there to find the perimeter.
Mm-hmm.
And we know this side is 4. So what is x? You're solving for the hypotenuse of a triangle. We'll call that C.
So can you say 7? So that's,
We're solving for C.
yeah. So that would be 49 plus 9.
Square root of 58. Let's just look at our answers and see if we see an answer in there that's got square root of 50. Aha! Right there. So what's the answer?
8 plus
Square root of 58.
58, so B?
Uh-huh. Yeah, because the perimeter is 3 plus 5 plus x. And x is square root of 58.
Okay.
Okay. Notice that can't be simplified. I was thinking it could be, but it's not. It's 29 times 2. That's actually...
I couldn't think of anything that could, make it a whole number.
Uh-huh. Well, that's the first one we haven't needed a whole... That's the first one where there hasn't been a whole number. It's an irrational number as an answer.
Mm-hmm.
Okay, so we have x, 2x, and 3y.
Mm-hmm. And then which of the following expresses a true relationship between x and y in the figure above?
Notice that all of our answers are equations involving both variables.
Uh-huh.
So
I would say it was D.
Well, give me an equation. Let's do this step by step. What equation do we know?
We know that x plus 2x plus 3y is equal to 180.
All right, that's what we want to start with. Now let's simplify that.
3x plus 3y is equal to 180.
Okay, now what?
Well, you either have to solve for x or y.
Well, some of these answers are in y, some of them are in x. Let's try solving for y. We'll see what happens.
Yeah, because there are 3 of those.
Yeah.
Minus 3x, and then it's y is equal to 180 minus 3x divided by 3.
Which is? In other words, simplify that by breaking it into 2 fractions.
Well, it's 60. 180 divided by 3 is 60, right?
Right?
And then it would just be minus x.
Which is answer A.
Hey.
Okay? Here's something that let me review with you, because this is pretty important. It's not geometry, but it's algebra. If I have A plus B over C, I can separate that into A over C plus B over C.
That's A over C, yeah.
If I have A over B plus C, I cannot separate that. That is not equal to A over B plus A over C.
Mm-mm.
In order to separate it into two fractions, you have to have a single term in the denominator, not a binary. Okay. So we also had 3x plus 3y equals 180. I could solve this for x. X is going to be 60 minus y.
But that's not an answer.
Right. We have an x equals 90 minus y. That's that one. So, all right. What is the perimeter of the big triangle? Again, we have to do the intermediate steps, which is find out all of the appropriate sides. You know, that's 9, that's 15, and that's 30 degrees. So to get the perimeter, we're going to need this side and this side.
Well, the side that's the height is 12.
Okay.
Which is x. So the hypotenuse in that triangle is 24.
Okay.
And then
What's this measurement from there to there?
12 square root 3.
Now what's the perimeter of the whole triangle?
Well, when you have to plus 9 or add 9 and 12 square root 3, did you say 12 plus 9?
Yes, that's exactly what you do. In other words, they're kind of unlike terms. You can't really add them. I mean, we could convert square root of 3 into an approximate decimal and add them, but that's not in the answers. If we look at our answers, everything has root radical signs. So we don't want a decimal answer. We want to add this, 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 and this. What do you get when you add those four numbers?
Well, I got 60 square root 3, but that's not an answer.
No, actually you can add 9 to 15. I can add 24 to that. That's 48. Plus this final piece, 12 root 3. So this is my answer. And notice that is on there.
Yep. I think it's just because I wanted to say that 12 plus 9 is 21. That's what I made the
Well, you added the 12 to the 48 and came up with 60. Well, the 12 to the 9 and came up with 21, same thing. But you can't do that. In other words, you cannot add 12 root 3 to 9 and come up with 21 anything. You just
well, I ended up with 21, you know, square root 3, and then I added it, and I just added the square root 3. That's what I made the mistake.
But these, notice, this is not 9 square root 3. We cannot add 12 square root 3 to just 9. That's like adding apples and oranges.
Yeah.
Okay.
But, you know, since I noticed that that's not on there.
Okay, what's the area?
So I'm asking what the area is.
Okay.
The area is... The base is 21 square, or 9 plus 12 square root 3.
What's
And
the
the
height?
other 12.
So let's simplify this. Times 12, excuse me.
Mm-hmm.
What's the best way to simplify this? Because that's not on there as an answer.
Yeah, what are the answers?
Right here?
Okay.
What's the best way to simplify this right off the get-go? Everything's being multiplied. In other words, this 1/2
Say 2
multiplies.
into 12.
Okay, so I can take away the 1/2 and turn this into a 6 for starters.
6.
So now I have 9 plus 12 root 3 quantity times 6.
Mm-hmm.
Distribute the 6, what do we have?
Oh, you want to say 6 times 9, which is 54, plus 6 times 12. And that's the answer.
That's the answer.
Okay.
Okay. Let's do one more here. Oops. Okay. Now, in these sections that I'm using, they have a quantitative comparison set of problems, which probably wouldn't hurt you going over, but the GMAT doesn't have those. They have data sufficiencies instead. So it's probably better if we don't go over those just so we can cover more material. Let's take a look at lines and angles, which is the first part of geometry. I didn't start there merely because this one's hard to read, and I didn't want to start you out with trying to read my bad photographs. But this is kind of a clever problem. Number 1, this is all about lines and angles. They want the average of the measure of the 5 angles. Let me tell you what they are. This is 2A, that's 3A, that's 4A, that's 5A, that's 6A. What's the average of those?
6A.
What's that?
I'm just writing it down, sorry. You said
Okay.
2A, 3A, 4A, 5A, and 6A.
Right. What's the average angle there?
Well, that's 360 divided by 5.
There you go.
Right?
That's exactly right. Notice it didn't have anything to do with A. Doesn't matter what these angles are. I could have made these angles anything in the world. I could have split it up like this.
The answer is D.
Right. In other words, the measure of 5 angles that make up a circle is always 72 degrees, is always their average, whether they're in this relationship or not. We're merely going to take 360 degrees divided by 5 angles. In other words, this is kind of a trick question.
Yay, I got it right.
Yes, you did. Well, and you got it right immediately. You didn't try to figure it out in terms of A. A had nothing to do with it. Let's end it with this problem here. This is an interesting problem. All of the angles north are A, all of the angles south are B. They want to know what is B plus A divided by B minus A.
Okay, well, I mean, my first initial thought was to say, well, all the A's plus together is 180. So why don't you just say 180 divided by 5?
There's actually 6 A's.
Oh, I can see that. Sorry.
It's all right.
So 180 divided by 6.
So A is 30 degrees. What is B? There are 5 B angles.
So it would be 180 divided by 5.
So what is B plus A divided by B minus A?
Well, B plus A is 66, yeah. And then that's divided by 6, that's 11.
That's the answer.
Great. Okay.
All right. Why don't we end there, and
Yep.
we can pick up from there next time. If you want to stay on geometry, there's one disadvantage in doing this, and that's that we get no time on data sufficiencies. So maybe at our next session we should do 45 minutes on geometry and 15 minutes on data sufficiencies pulled from GMAT tests.
Yeah, and actually, on next Sunday, I actually booked it twice, like 2 hours, like right after each other.
That's fine. I saw that, and that's perfectly fine. So
Yeah,
we'll
it's
do an
just
hour and a
then
half.
can.
Maybe we'll do an hour and a half of geometry and 30 minutes of data sufficiencies. I don't want to completely ignore data sufficiencies because they're the hardest part of the test.
That's also what yeah, that's where my biggest flaws are.
Okay.
And I'll just keep trying to do the other, and maybe as we go along, maybe we can just have a day where we do like various questions to try and keep the brain working.
Right. Right. Let me just show you briefly what I have here in the way of discrete geometry. We looked at triangles. We did all the triangle questions. We're working on lines and angles now. There's also quadrilaterals, four-sided figures. There's also circles. There's 15 questions on circles, and then there's 15 questions on solid geometry and then coordinate geometry. So I've got a lot of geometry questions. How long you want to focus on geometry is totally up to you.
Yeah, let's just see how it goes along, because
You'll notice that some of these others are algebra. These are algebra word problems. These are inequalities. These are averages. These are polynomials. So these are more algebra problems, whereas geometry problems are lines, angles, triangles, quads, circles, so forth.
Well, I mean, as far as we can go, great. So yeah, let's just try and do as many problems as we can. So.
Okay. Does this feel a little bit better concentrating on a single aspect of math, like geometry?
Yeah, because I feel like if I focus on one thing, I'll get better at that, but I also have to remind myself that on the test, it's going to be different things, So.
Well, before we finish, we should definitely do tests also. It's it kind of depends on how many sessions we're going to have, but why don't you keep that in mind? If we come down to where we're going to have exactly 2 more sessions before you take the test, we should be doing tests.
Okay. I mean, I'm kind of planning on just maybe, practically like when I get back to the U.S., I'm planning on just scheduling perhaps every day.
Okay.
Just because it's getting down to crunch time, so.
Okay. All right.
Yeah.
Well, I think we have a pretty good plan of attack then.
Well, that's great. Well, I really appreciate it. So, and
You're welcome. And
I hope you have a great trip to Florida.
Thank you, and enjoy your trip from Denmark to the United States.
Thank you so much. Have a great rest of your day.
You too. Bye-bye.
Bye.